In this video of solving other types of equations, we're going to solve equations involving radicals. Here, as I look at this problem, we have a radical in the middle of our equation. So your first step on something like this is to isolate that radical. So what I'm going to do is I'm going to add this entire value to each side. I'll go ahead and show that. Anything I do to one side, I'm going to add that entire radical to the other side. And now we have x equals the root of 15 minus 2x. Now that we have the radical isolated over here, our way that we get rid of the radical, because remember we're trying to isolate the x, so my next step is to get rid of the radical, and the inverse operation of square rooting is to square. Anything I do to one side, I do to the other. So what we now have is we have x squared on the left side of our equation, and on the right side, since the exponent and the radical are inverse operations, it's just going to leave you with 15 minus 2x. And now you can see that we have a quadratic. Once I rearrange my equation and set it equal to 0, you could solve this using whatever method you want. I'm going to solve with factoring. And so if my factors are x plus 5 and x minus 3, that means that the solutions will be x equals negative 5 and x equals positive 3. Now, you really have to be careful with these type of equations with radicals. You always want to check for extraneous solutions. And what I mean by that is we want to take our answers and substitute them back in and make sure they work. Make sure that this actually gives us a true statement. If I substitute 3 in there and I substitute 3 in there, does it actually subtract to give you 0? And what I think you'll find, and hopefully what you'll find, is that this solution right here, it works. It ends up giving you 3 minus what becomes a 3 once we simplify this, and 3 minus 3 is 0. But the negative 5 actually doesn't work. If I take negative 5 and I subtract, this would have to be a negative 5 under the after you square root it, and it's not going to be. So this is we use legitimate means to get to this solution, but it's extraneous. It produces a solution that doesn't actually work. So always check for those extraneous solutions by substituting your answer in. Here's our next problem. Now this problem actually requires a lot more work because we have two different radicals that are in two different terms. So we're still going to follow the same method we did last time. It's just going to get a little bit hairy algebraically. So what I'm going to do first is I'm going to isolate one of my radicals, and it doesn't matter which one. So I'm going to add this root of x plus 1 to each side. So the right side of my equation is now this. Now what I can do is I can get rid of the radical on this term on the left side of my equation by squaring that side of the equation. But anything I do to one side, I have to do to the other. Over here on the left, it's convenient because the exponent undoes the radical and just leaves you with 2x plus 3. But over here, you have a binomial. I have two different terms. So separated by a plus sign. So I have to come over here and do some aside work. So I have, anytime I square a binomial, that means I'm multiplying it by itself. And here's where these problems can get a little bit, as I said, hairy algebraically. 1 times 1 is 1. 1 times the root of x plus 1 is the root of x plus 1. And then the root of x plus 1 times 1 is another root of x plus 1. And then root of x plus 1 times root of x plus 1 is just anything times itself is that value squared. And now let's simplify a step further. My 1 is there. These two terms can combine. If I add anything to itself, that means you have 2 of whatever that is. And then as we mentioned earlier in this problem, when you square something that's being square rooted, those are inverse operations, and it will leave you with the x plus 1. So that's really what the right side of our equation becomes. It becomes all this stuff. 1 plus 2 roots of x plus 1 plus x plus 1. I just took all this stuff and copied it over here. And now, we got to play the same game again. We initially isolated this radical, but if you'll notice, we still have a radical in our problem. Our next little mini goal is going to be to isolate this radical and then square both sides again. So I'm just going to take it step by step. I can subtract x from each side. And then it looks like I have a 1 that I can subtract there and a 1 that I could subtract there. But if I subtract 1 twice on the right side of my equation, I'm really subtracting 2. So I got to make sure I do that to both sides of my equation. So we are left with 1x plus 1 equals the root, or 2 roots of x plus 1. And so as I said, we are trying to isolate that radical, so the last thing I'm going to do is I'm just going to divide by 2 on each side. And we have this root of x plus 1, and that's going to be equal to x plus 1 all over 2. In doing that, we've now isolated our other radical. So we isolated the first radical, squared it, did all of our algebra, isolated the second radical. Now we're going to square it. Anything I do to one side, I do to the other. So on the right side of my equation, the exponent cancels with the radical, and that's going to leave us with x plus 1. On the left side of my equation, I'm squaring both the numerator and the denominator. The numerator is that, the denominator, 2 times 2 is 4. I didn't show the work going from x plus 1 squared to this, but that's just coming over like we did up here and taking x plus 1 times x plus 1 and multiplying it out. And now we have this little equation to solve. We're getting close. We're almost there. So I am going to, and you don't have to necessarily do this, but I'm going to multiply each side of my equation by 4. And that leaves us with x squared plus 2x plus 1, because that cancels, is equal to 4x plus 4 once I distribute. And let's just come up here and let's finish this problem out. I'm going to change to black. So we have x squared plus 2x plus 1 equals 4x plus 4. We have a nice little quadratic. So I'm going to rearrange it and collect all my terms on the left side of the equation so that the quadratic is equal to 0. I'm going to solve by factoring. But if you're not comfortable with factoring, you could solve with the quadratic formula. And so from this factor, if x minus 3 equals 0 with the zero product property, then x must equal 3. If x minus 1 equals 0 via the zero product property, then x must equal, negative 1. And so what we find with these is, do not forget, with these problems involving radicals, take them and substitute them back in and make sure they work. I would take this 3 and I would substitute in there, and I would substitute in there, and I would do all the math and make sure that when I subtract this minus this, I get 1. And I do the same thing with my negative 1. I put a negative 1 in there and a negative 1 in there. I'd figure out what this is, I'd figure out what this is, and subtract, and make sure it works. Make sure it satisfies this equation. In this situation, I'm not going to make this any longer by doing that checking, because these both end up working. These are both good solutions to this equation.